Okay, so here's an example that I would like you to do. So I'm going to go ahead and just have you pause the video. I'm going to have you read through the problem and then see if you can set up the test and perform the test and interpret the results. And then once you've given that a try, you can start the video again and we'll look at it together. Okay, let's go ahead and look at this. So this says that the Ford set the gas mileage standards for a new vehicle at 27.5 miles per gallon, and to test whether the standards are being met, a sample of 50 vehicles is selected, and it has a mean of 26.7 miles per gallon with a standard deviation of 2.8 miles per gallon. So we want to test at alpha equals 0.01 whether the true mean gas mileage is less than the standards that are set by Ford. Okay, so these standards are the hypothesized mean. We don't know if they're being met or not. That's what we're wanting to test and see. And so the null hypothesis is going to say there is no difference. The standards are being met. They are equal to 27.5 miles per gallon. Okay, and then the alternative hypothesis that I would like to show is that is that the true mean number of miles per gallon is less than 27.5, less than the standards that are met by Ford. And in that case, they wouldn't be meeting their standards, right? So if it were greater than that, they'd be exceeding the standards. If it's less than that, they are not meeting the standards. So we want to see if we have enough evidence to reject H0 in favor of the alternative. So this is a left-tailed test. My alpha is equal to 0.01. I'm going to shade the left tail. And I'm going to go to my t-table. And I'm going to go to alpha, one-tailed alpha, 0.01, down to the bottom. My critical value is 2.326, and I need to make sure to put a negative sign there because it's a left-tailed test. So it needs to be on the left side. There needs to be a negative sign. And then if you're on this side, you would reject H0. If you're over here, you would fail to reject H0. So the question is, what side of that is the test statistic on? So my test statistic would be the sample mean minus the hypothesized mean. Divided by the standard deviation over the square root of n. So let's see what I get there. So 26.7 minus 27.5. Hit return. Divide the answer. Got to make sure this is in parentheses. Square root of 50. I was going to say, if you forget this parentheses, then your test statistic is going to be really, really tiny because it's going to divide by 2.8 and then divide by this as well. Divide the answer by that, and that's not what you want. You got to have this in parentheses so it divides this first, and then it divides the top by a smaller number here. Okay, so you got to have those parentheses there, and when you do, you get negative 2.02. And negative 2.02 actually does not lie in the rejection region. Okay, it lies in the fail to reject region. So I'm going to fail to reject H0. And so my final decision, there is not enough evidence to conclude. So there is not enough evidence to conclude. And what is there not enough evidence to conclude? That alternative hypothesis. So to conclude that the true mean miles per gallon is less than 27.5. Okay, so there's not enough evidence to conclude that it's less than this, and so we're going to go ahead and assume that Ford is meeting their standards. So I'd have to have enough evidence to reject this in favor of that it was less than in order to show that they were not meeting their standards. So in a sense, you can almost think of this as the company is innocent until proven guilty. Okay, the car is meeting the standards until there's evidence to show that it isn't. Okay, so very good. We're going to do another one of these. So let's do the same thing on the next video. I'll have you pause and try it yourself before watching me do it.